Again, there are different types of halogen: chlorine, bromine, and iodine. Sunlight or heat. We know that chlorine is more reactive for halogenation than bromine, right? And iodine is least reactive. Iodine is least reactive for halogenation, but chlorine is more reactive than bromine, right? When there is chlorine and bromine and you are carrying out the halogenation with alkane, so chlorination first, then bromination, right? When chlorine is added, that is called chlorination. When bromine is added, that is called bromination, right? The another one is that when alkane, you know very well, methane, ethane, propane, butane, pentane, hexane, heptane, octane, nonane, decane, and indica, and so on, right? And there are isoalkanes, neoalkanes, and normal alkanes. We know very well. So when we react with butane or propane, we get mixtures. We not get a single compound, right? We are not getting a single compound. When we react with this propane with chlorine or sunlight, in the presence of sunlight, we get more than one product. That is, one is propyl chloride and another is isopropyl chloride. I mean that when we are treating with alkanes, suppose propane or butane, when right, not a single product. I will discuss the reason later. Another is the fourth condition is we have different types of alkanes. You see here propane, the central carbon is secondary. The central carbon is secondary carbon, while its terminal carbon are called primary carbon, right? So which one is more reactive? Secondary hydrogen substitute with this chlorine first, or primary hydrogen substitute with this chlorine first? This is the question, right? So we get two types of product. One is by substituting of hydrogen with this hydrogen, and another is substituting of hydrogen with this secondary hydrogen. Which one is more reactive? That substitute first. And we know very well that in case of hydrogen, tertiary hydrogen substitute first, then secondary hydrogen, and secondary hydrogen is more reactive than primary hydrogen, right? Then methane. As this case is this is fourth case, while fifth case is chlorine is more reactive than bromine. So whenever you are carrying out a reaction with alkane and chlorine, it is too much reactive and chlorination takes place, non-stop chlorination takes place. But when we are if we want to carry out the selective halogenation, we are using bromine instead of chlorine, because bromine is more selective than chlorine. But when we are talking about the reactivity, chlorine is more reactive, no doubt. But selectivity की बात करते हैं तो bromine is more selective, right? We will see all these with examples. Suppose when ethane, there is both carbons are primary carbon. You see here, one carbon is directly bonded with another carbon, that is called a primary carbon, right? When this ethane reacts with the chlorine, and a photochemical reaction you are carrying out lead to the formation of ethyl chloride, single product you are getting, because there are both carbons are primary carbon, right? In propane, there are two types of carbon. One is primary carbon. Two carbons are primary in nature, while central carbon is secondary in nature, because one carbon is bonded with one carbon is directly bonded with two carbons, that is called secondary carbon. It means that there are two types of hydrogen in propane. One is primary hydrogen and another is secondary hydrogen. Primary hydrogen, the hydrogen attached with primary carbon is called a primary carbon, primary hydrogen, and the hydrogen attached with secondary carbon is called secondary hydrogen. When we carried out reaction with propane and chlorine in the presence of sunlight, two types of product we are getting. One is N-propyl chloride, normal product we are getting, that is 45%, and another product is isopropyl chloride, right? That is 55%. Which one is major product? We know very well 55% isopropyl chloride is the major product, then normal propyl chloride. So the question is, why it is so? Why it is in maximum? Why it give maximum yield than normal propyl chloride? We have already discussed in our lecture that secondary hydrogen is more reactive than primary hydrogen, right? Therefore, you see here, there is two types of hydrogen. This is primary hydrogen, this is primary hydrogen, while central hydrogen hydrogen attached with central carbon is secondary hydrogen. So secondary hydrogen is more reactive than this primary hydrogen. Whenever we are carrying out photochemical reaction with this chlorine, they are react with secondary hydrogen, lead to the formation of isopropyl chloride in maximum quantity, that is 55%, while normal propyl chloride we are getting, that is this halogen is substitute with this primary hydrogen, right? As a result, we are getting 45% minor product, right? Basically, we are getting a mixture of product because there are different nature of hydrogen available. One is primary hydrogen and another is secondary hydrogen. And we know very well secondary hydrogen is more reactive than primary hydrogen. Therefore, hydrogen substitute with this secondary hydrogen first lead to the formation of isopropyl chloride, and primary hydrogen substitute with this chlorine lead to the formation of propyl chloride in 45% as a minor product. But overall, we are give a mixture of both possible alkyl halides. There are two different types of alkyl halide. If you see here, N-butane, you see here again, there are two types of carbons. One is primary carbon and another is secondary carbon. The terminal carbon are called primary carbon because terminal carbon is directly bonded with one carbon. While the center carbons, there are two carbons in butane. These carbons are directly bonded with two carbons. These are called secondary carbon, right? When photochemical reaction carried out with this chlorine, as a result, we get 28% butyl chloride product. We are getting with as primary hydrogen, while secondary butyl chloride we are getting in 72%, because in secondary carbon, as the secondary hydrogen is substituted with this chlorine through free radical reaction, we get 72% secondary butyl product. Basically, we are getting free radicals in the presence of sunlight, and we are getting three types of free radical. One is primary free radical, secondary free radical, and tertiary free radicals, right? We know very well, if we compare the stability, tertiary free radical is more stable than secondary free radical. Secondary free radical is more stable than primary free radical. Therefore, this product in this stage, there are secondary free radical form first, therefore, which is more stable than primary free radical at this carbon. Therefore, 72% secondary butyl chloride form, while 28% butyl chloride form as minor product, right? Here you see isobutane. Again, there is some problems you see here. When it reacts with chlorine in the presence of sunlight, यहाँ पर tertiary carbon से हाइड्रोजन एलिमिनेट होना चाहिए था और मेजर प्रोडक्ट ये बनना चाहिए था, ठीक है, लेकिन ये 36% बनता है। ऑन द अदर हैंड जब ये प्राइमरी हाइड्रोजन से प्रोडक्ट जो बनता है वो आइसोब्यूटाइल क्लोराइड, ये जो प्रोडक्ट बनता है ये 64% बनता है। ऐसा क्यों बनता है? इसकी वजह ये है, देयर इज स्टेरिक क्राउडिंग, नो डाउट टर्शियरी फ्री रेडिकल इज मोर स्टेबल। यहाँ पर ये हाइड्रोजन इलिमिनेट हुआ तो होमोलिसिस के जरिए इलिमिनेट हुआ तो टर्शियरी फ्री रेडिकल तो बनता है, लेकिन देयर इज स्टेरिक क्राउडिंग, सो इनकमिंग जो क्लोरीन है इसके लिए मुश्किल होता है एज कंपेयर टू दिस वन। तो इसी वजह से स्टेरिक क्राउडिंग की वजह से ये प्रोडक्ट जो है वो कम बनता है इसकी निस्बत, राइट। इसी तरह से जब हम इथेन के साथ ब्रोमिनेशन करवाते हैं इन द प्रेजेंस ऑफ सनलाइट, इथाइल ब्रोमाइड ऑब्टेन, राइट, और प्रोपेन के साथ हम रिएक्शन करवाते हैं तो अगेन देयर आर टू टाइप्स ऑफ कार्बन, वन इज प्राइमरी कार्बन एंड अनदर इज सेकेंडरी कार्बन। जो प्राइमरी कार्बन के साथ रिएक्शन करेगा वो हमारे पास सिर्फ 3% प्रोडक्ट हासिल होता है, 3 प्रोपाइल ब्रोमाइड, और जो सेकेंडरी कार्बन है इसके साथ रिएक्शन करके आइसोप्रोपाइल ब्रोमाइड बनता है, दैट इज 97% मेजर प्रोडक्ट। क्यों बनता है? बिकॉज दिस फ्री रेडिकल इज मोर स्टेबल, सेकेंडरी फ्री रेडिकल इज मोर स्टेबल देन प्राइमरी फ्री रेडिकल, इसी वजह से 97% मेजर प्रोडक्ट हासिल होता है, ठीक है। अगेन यू सी हियर एन ब्यूटेन के साथ जब हम रिएक्शन करवाते हैं, एज आई हैव ऑलरेडी डिस्कस दैट, जब हम यहाँ पे क्लोरिनेशन में कन्वर्ट देखते हैं तो यहाँ पर क्लोरीन और इसमें परसेंटेज कम थी, लेकिन यहाँ पर परसेंटेज ज्यादा है ब्रोमीन के केस में। इसकी वजह यह है, I have already discussed that in here in bromine is more selective. No doubt chlorine is more reactive, but bromine is more selective, right? We get our required product through bromination more as compared to chlorine because bromine is more selective. So selectively it will attack with secondary, it will react with secondary free radical is more than प्राइमरी फ्री रेडिकल। इसी वजह से जो आइसोप्रोपाइल ब्रोमाइड बनता है वो मेजर प्रोडक्ट बनता है और ओनली 3% प्रोपाइल ब्रोमाइड हम हासिल करते हैं। इन दिस केस ब्यूटेन की केस में आप देख लें यहाँ पर 2% माइनर प्रोडक्ट हासिल होता है और सेकेंडरी ब्यूटाइल ब्रोमाइड 98% हम हासिल करते हैं, क्योंकि दिस वन इज मोर सेलेक्टिव देन। जब हम यहाँ पर हेलोजिनेशन करते थे ब्यूटेन के साथ, आप देखते हैं 72% हम हासिल करते थे मेजर प्रोडक्ट, लेकिन सिंस ब्रोमीन इज मोर सेलेक्टिव therefore we are getting 98% product, secondary butyl bromide we are getting at 98% because bromine is more selective than chlorine. Normal butane again it reacts with, there are two types of carbon, one is primary carbon, terminal carbons are primary carbon while the center carbons are called secondary carbon. So hydrogen from center carbon से जो फ्री रेडिकल बनेगा वो इजीली बनेगा, ठीक है। तो सेकेंडरी फ्री रेडिकल ज्यादा स्टेबल होता है प्राइमरी फ्री रेडिकल की निस्बत, इसके जरिए जो प्रोडक्ट बनेगा प्राइमरी फ्री रेडिकल के जरिए वो बहुत ही कम बनेगा 2%, वाइल सेकेंडरी फ्री रेडिकल के साथ जो प्रोडक्ट बनेगा वो बहुत ज्यादा बनेगा, क्योंकि सेकेंडरी फ्री रेडिकल इज मोर स्टेबल देन प्राइमरी फ्री रेडिकल एंड यू आर गेटिंग 98% प्रोडक्ट. In case of isobutane, you see isobutyl bromide में मेजर ये जो माइनर इंतहाई लेस देन 1% प्रोडक्ट वी आर गेटिंग, while tertiary butyl bromide में this one we are getting 99% प्रोडक्ट, while in case of chlorination this is very less reactive. हम यहाँ पे कर रहे थे तो 36% बन रहा था, क्योंकि इसकी सिलेक्टिविटी रिएक्टिविटी ज्यादा है लेकिन सिलेक्टिविटी कम है. So in case of isobutane, when isobutane react with bromine through photochemical reaction, we are getting less than 1% isobutyl bromide and tertiary butyl bromide in 99% product we are getting, right? Because bromine is more more selective than chlorine. No doubt, chlorine is more reactive, right? Any question? Any question?
Sir. Yes, sir. Question here.
Any question?
question, sir. Hello, sir. आवाज आ रही है?
Yes, yes. You can ask question.
सर आपकी आवाज कट रही थी, कुछ समझ